And also, because it wouldn't fit in there, I wrote by hand. Please also have your homework out, because we're going to go over your homework first. And your spinner for Friday, and your name tent. If you need a new name tent, make one.
Oh, wait.
There should be blank ones, so catch up with your group. They took all my blank ones. You are welcome. Okay, that part was wrong. So if you don't have your homework finished, that's okay. Please don't try to hide it. We're not playing that game. If you don't have it finished, it's okay. Just get out your math journal. We're going to go over it together, and if you don't have it finished, you're going to finish it right now. You guys can always slip in here like behind that back counter and grab that one right there. You don't need to ask for permission. My stuff is your stuff. That make sense? Sweet. Right there, the big note cards. Sure, whatever. You really want to drink out of my water bottle?
I don't. I have my own.
So this spinner, which you should have colored in from last week, if you were absent, you might need to copy off somebody from your group. And your homework from the weekend, which, I need to get back up. So guys, this is your opportunity to kind of have a reset, because I know some of us didn't do our homework, and I told you it's not really due till the next, like, 2 business days, so it wouldn't be the next school day, it'd be the following school day. So really I would not collect this until tomorrow, but if I were collecting it today, like let's say, we're standard school, whatever, and I collected your homework the day after we had that class, do you have it done, and do you have it done correctly, is the question to ask yourself. Would you get a check on it? So this homework assignment is going to be freebie, right? We're going over it together. If you don't have it, write it down, finish your work right now. If you do have it, check your work, ask me if you have questions. Moving forward, there will be a math journal check sometime in the next few days. This is going to be the checkpoint of we all went over this together. We should all have the same thing. So from this homework forward, that's what I'm going to be keeping track of and checking. Okay? Not trying to play gotcha. You guys just need to stay organized. You need to work on your assignments. I know there's some of you kind of weaseling your way out of not doing your homework. That's really bad. Really not good for your brain, guys. So 157, Joyce's dad picks yogurt randomly for her. The highest probability she will get is strawberry. Can anyone explain why that happens?
That is because all the other yogurts are just one. However, strawberry, there's 2 of them. So.
Oh, sorry, I froze my screen. You can't even see.
So
If you guys think I'm like crazy, tell me that you think I'm crazy, because if I've frozen the screen right here, I might be screwed up. Letter group O, Levi, you guys are just hanging out in the library. Sweet. All right, so there's one of every yogurt except strawberry. There's 2. Now, can you continue on, Will, and tell me how we get 1/5 for B?
For me, I think 100% or 1/5, and that is because there's 2 strawberry and altogether they add up to 10. So
They add up to 10?
for the
1 raspberry, 2 strawberry, a blueberry, and a vanilla. So when we're doing the probability, we would write P parenthesis and then whatever event we're looking for. So here, that would be vanilla, probability of vanilla. How do I build this fraction? Who can tell me the words that we talked about last week, how I build this fraction? What goes where? Diane, do you remember? You're like staring at the wall over there, dude. Do you remember what goes on top, what goes on the bottom? Not numbers, but words. How we build probability. Exactly. If you can't remember, flip back in your notes. Yeah. Name tents, guys. If you don't have your name tent, please get it out. Your group needs it just as badly as I do. A lot of you don't know your peers' names. Thank you, Annie. So Amy, how'd you get 1/5?
Well, the bottom, the denominator is the total,
Denominators always our total amount.
and then the numerator is like the number of what you're
What
looking
are
at.
you looking for, bud? I might have to get more out. You need big note cards. But lose your name tag, dude. Yeah, the top is what we want. So the event that we want gives me my numerator, how many times it happens, and the total events that are happening gives me my denominator. I might have to find some more giant note cards. We can use standard sized ones for this time. It just won't be as fun. Well, it's not as big. Not always. Like a wound, bigger's not better on that. Oh, yeah. Alright, moving on. 58, you should have drawn a number line. Now, why is our number line from 0 to 1 here, and that's it? Now, I actually don't like that they put the arrows on the end. You don't need those arrows. Why 0 to 1? Yeah.
Because when for probabilities, the number line only needs to be from 0 to 1 because 1 acts like 100.
Good morning, Sky Everett. Please come to the office. Sky Everett, please come to the office. Thank you.
So we say that the 1 is certain. What would we say about the 0?
It's like impossible.
It's impossible. Now, I would always put a half on here as a reference point so that I know 5/8 is slightly over half. So I added my half as a reference point. My 25% is halfway between 0 and a half. My 80% is a little over halfway between a half and 1. My 0.01 really just means 1%. Now, nobody would ever actually say this. There's a 1% chance or 0.01 probability that it will be 85 degree zones. What? Nobody would really say that, but they're just trying to give you a statement of place on there. Questions on 58? 59, we're looking theoretical versus experimental, so check those. Did you get that right? Theoretical versus experimental? Who can remind me how I determine theoretical versus experimental? Annie?
Experimental, you have done it and collected the data, and theoretical, you're just guessing at the data.
Theoretical, we were given information, we didn't do anything, and we just find our probability off that. Experimental, exactly what Annie said, we did it. We physically did something. We flipped it, we spun it, we turned whatever the event is. We chose the yogurt, whatever your event is, we did it. Moving on to 60. Oh, sorry. T-E-E, T-T-E. T-E-E, T-T-E. T-E-E, T-T-E. Alright, so what does percent mean? Anyone remind us what percent actually means, Alex?
100 per.
Yeah, like out of 100. So if we want to make box diagrams for this, and we have 100 boxes, well, however many are shaded is our percent. So and I'm going to talk about A and B at the same times, I has 80 boxes shaded. So we could set up a fraction 80 over 100. But really, I could just look at columns and say there's 8 columns shaded out of the 10 total columns. So I could also say 8/10. The 80 hundredths is nicer because it leads me right to my percent. Same with double I. That has 12 and a half boxes shaded. The half box is kind of weird. 12 and a half boxes shaded. So I could set up 12 and a half out of 100. Or actually, that reduces to an eighth. But the 12 and a half over 100 is exactly what I want for determining my percent. And then 10 over 100 or 1/10 gets me 10%. Any questions? On 61, remember mean is average and median means middle. As you're on the highway, hopefully you're not the one driving, but as you're on the highway, the big cement wall in the middle of the road, that's the median. It's the middle. Separates traffic, keeps you safe. If there is none, there's still a median. It's just grass or whatever. It's the in-between, the middle. So what median really means is half is above, half is below. So anyone ever watch Bar Rescue with John Tapper? I like restaurant science. There's a lot of like math in restaurant science. So he goes and he saves these restaurants, and there's always a whole bunch of math involved. And they talk about the median age because they want to know what's the middle age of this area. Columbus? What do you think the median age of Columbus is? Do you think it's like older, like 50, 60, or younger, like 20, 30?
Older.
It's younger. Columbus is a pretty young city because all of downtown and like these young business people. I mean, there are a lot of adults like in the 40s and 50s. But think about Ohio State University, Capital University, Audubon University, like all these different colleges. There's a lot of young people in this area. So if we looked up the median age of Columbus, I bet it's younger. Because I already went over this in the morning, I kind of give you a bit too much here, but we're also the Accelerated 7 class, so I hope we're decent at reading a histogram or a frequency graph. Sorry for moving around so much. So when I look at my histogram, I can determine the frequency. What's frequency? Somebody help me out. What is frequency? If you don't know, this graph's going to be really hard to read. Where's your name tag? I've said it 3 times. It's all good. So, just go ahead and tell everyone your name so we can help. Alana, and your name tag's right there, actually. I knew that because you left it in my room. That's why I asked you, where is it? Sorry. Kind of playing a joke. But, Alana, how? You guys got to keep track of your stuff, otherwise I get to have a little bit of fun. What is frequency, Alana? How often something happens, or how many times it occurs. So, how often is a little different than how many times. Like, how often could be every 5 minutes. Here, we just have how many of these pitches he threw. This, we'll talk more later, means broken graph. His graph does not start at 0 and go up sequentially. But the y-axis is not broken. It goes exactly how it should. So, here I can see there's a frequency of 1, frequency of 5, and so on. The problem with a histogram, what A is getting you to identify. Do we know the specific speed of this pitch? Or the specific speed of these pitches? No, but we do know a range, right? So we know these two fall into what range? 70 to 75. They could be 72, 73, 74, 75. We don't know. But it's in that range. So, when B asked what's he normally pitch, I would actually totally be fine with you saying 50 to 65. Because 50 to 55, although that's the highest concentration, all of these are pretty high happening. 5, 3, 4. So if we look at that chunk together, that's 12 of the 16 pitches here. That's a lot. That's 75% of his pitches are right in this range. So either of these answers are totally fine. And then with how we calculate probability again, remember, it's what you want out. Come on. It keeps trying to fall. It's what you want out of your total. So we have 2 pitches in that fast range. Out of our 16 pitches, we can do the division, because this is awkward, 2/16. And when I think to myself, okay, to make it a percent, let's make it over 100. Yeah, that'll be fun.
Yep.
Turning 16 into 100? No. Now, I'm not saying we can't do it. I'm just saying it'd be awkward. So instead, we can do the division. We get our decimal answer, and we can convert that to percent by bumping that decimal 2 places to the right. We get 12.5%. Any other questions on those? So this is your chance to reset. I'm going to be checking your math journal from this homework moving forward the next time I check it. Okay, so please make sure that... So from this, my next math journal check, we'll be checking this homework onward. I'm not going backwards. So yeah, I'm trying to like... Now, if you had a check minus, you still need to fix that. Like, that's still a check minus until you take care of it. So, my next challenge for you is called the mystery spin. So go ahead and get out your math, flip to a new page or something that you can title. We need to date for today. What is the date today? It is the 5th, so 9/5. It's our date all day long. It's not Monday. By the way, I put your arrow on Monday. I'll shift it down to Tuesday. Your homework's the same as Math 7. We're lined up right now. Because you jumped over to the 8th grade textbook while they were still in the 7th grade textbook, and we skipped that stuff and bounced back. Yeah, we will be skipping through. So today's 1.2.2 for you numbery people that like knowing what we're doing. And we're going to title this activity the Mystery Spinner. So I need you to do two things for me. I need you to draw a circle and not worry about how circular it is. Just draw a circle. Then draw me a T-chart that we will track our results in. Our results will have a color, and then it will have frequency, or how many times that occurs. So my E is all jacked up. Please make sure you have this. I'm going to get more specific as I check your notes, guys, as I check your math journals. I'm going to be looking for things that I know we did together in class, and if you don't have it, it's going to be a check minus. And actually, I may just make the math journal a mastery grade for the quarter. So if you are master, it just stays at master. But then if I check it, and it could change down to a progressive, because if you're not keeping up with it. So I think I'm actually going to change the math journal grades into a living mastery grade. So I'm going to spin my spinner, and you're just going to keep track of results. I then am going to ask you to try to draw the spinner. Try to, so the best possible. So we just have the circle to start. We're going to section it out here in a minute. But so just keep tracking my results. All right, you ready? We all good? Spin 1. Landed on purple. So you know that purple is a color on the spinner. So we would write purple in my T-chart. So please write purple in the T-chart. Sorry, my 1P, but I'm not going back and fixing it. We're going to do tally marks. So don't make the number 1. We're going to do tally marks. Second spin. Purple. Third spin. Orange. Ooh, new color. Second on the purple. Fourth spin. Green. Ooh, new color. I don't know, depends how many there are. Fifth spin. Orange. Sixth spin. Green. Seventh spin. Purple. Eighth spin. Purple. When should I stop? How many? 10? Okay, let's go to 10. So we've done 8, right? So yeah. I'm missing 2 purples. You can't look. Purple. So now you slash across. You make the 5 set. Nope, gotta make the 5 set. Finish the 5. Last spin. Anyone want to predict?
New color.
Purple. discuss with your group. You don't have to agree, but I want you to discuss as you're working. You need to section out your spinner, and I will tell you there are no other colors. We've hit every color. So there's nothing that got left out. Everybody got to play. Try to fill in your spinner. I'm tired of drawing. So, now make sure that above this, you write like predicted, or like my guess, or something like that. So, predicted. Now the first thing I heard a couple groups say was, well, we should cut this into 10. We should make 10 sections. So I downloaded a 10 spinner. 10 sections. Can anyone tell me why you did that, and then how you started filling in? Alex?
Well, since you spin 10 times, like, we chose, like, the 10 spinner.
Ah. So since we have 10 results, we can plug in results to the spinner. Now, do I actually have 10 different things happening here? No. How many different results do I have? 3. So, as I go to start filling it in, Naya, you raised your hand. Then if I go to fill in my 10 spinner, how much am I going to make purple? 6, because we had 6 of them. So we would then make 6 purple. How many green? 2. How many orange? 2. Now, even if you didn't have that exactly, you had something close, or you didn't make 10 sections, you just eyeballed it, that's fine. But we're all wrong.
Oh, gosh.
We're all wrong. This is the actual mystery spinner. So I want you to talk with your group about why you think our spinners that we drew and predicted didn't end up being the same as what the spinner actually is. So take a moment, talk about that with each other. There's an extra what? I showed you. I showed you.
Only get 3. If somebody else did this experiment,
And then once you talk about this for a second, take a moment to put the actual spinner.
I mean, it's not.
And label that actual. Who can talk to me about why our spinner that we predicted was not the same as the actual, but yet we all had pretty much the same thing. Why? Okay, talk more. Now you keep saying probability. I'm actually going to switch that word out with like outcomes. So we did it based off our outcomes, right? We did some, like I spun some spins. I gave you information. You created the spinner based off info I gave you. What in the info I gave you is different or disagreeing with what the spinner actually is? You can keep going if you want to see. Purple. So purple had the most. Should purple have the most? Yeah, okay, so purple having the most is okay. What about orange green? Are they the same? So here the issue is these look equal. So my cues don't always connect. These look equal, but they're not. So when we go to the actual, we can see green's not equal to purple. Now I don't guarantee that this is exactly the same sizing as up there, but probably pretty close. And since we already had a 10 spinner downloaded, well, I just didn't want to work harder than I needed to. I want you guys to notate, if we use this as our actual, and hopefully you have it in your notes now, what then is the probability of orange? Or the probability of green? Or the probability of purple? What is it actually? May, we didn't really talk today. How can you figure out the probability of orange? What fraction are you going to set up? Yeah, 2 out of 10 because we have 2 of our slices are orange out of the 10. Zach, if I want to make 2/10 into a percent, it's nice to stop along the way with a denominator of 100. How can I get there? What can I do to my fractions? Now, what math needs to be done then? Yeah, we're really multiplying by 10. And that gives me 20%, which I keep dragging my background thing. Sorry, that's a percent sign. A really bad percent sign, but, A for effort. I tried my hardest. What about green? Well, what about green? What fraction are we going to start with there?
3/10, since it's 3 out of the 10.
Yeah, 3 out of 10, which we know would then become 30 out of the 100, and percent-wise is 30%. Now, I could figure out my purple by doing the whole fraction method, or, the alternative route I'm going to take now? What is the probability you will land on a color? 100%, right? So, Mina, do you know the way around that I was about to take?
Yeah, so you would just add the 2% piece of green and orange, which is 50. And then, so 50 instead of 3 is 100 subtract 50.
If we know, we have to add up to 100%. 100% means all outcomes. And I only have 3 different colors. And I already found 2. Exactly what Mina said. Add these up, figure out what's left, and purple has to be 50% just to work correctly in the percent system, out of 100 system. So please make sure you have all this written down. You could also have the 5/10, and then we get there that way. But we wouldn't have to. So I have some prediction challenges for you. So if you were following along in your book, this is pages I can't ever find. I think I'm out of order. Definitely. Took a page out, that's why. 32. If you're following along in your book, we're on page 32. But I think we're actually probably beyond that now because we've already talked about a couple of those questions. So, we are going to look at 66. Really, D and E. So you can look at the other questions. We've kind of already discussed those. I think we're pretty good on the experimental versus theoretical. Like, I could have showed you the spinner from the get-go. Like, if I'd shown you this, you guys could have probably quickly told me, well, green's more likely than orange. But when I gave you the experimental results, that communicated that they were the same. So that's the danger between experimental and theoretical. So now with our theoretical, now knowing what the spinner actually looks like and having the actual information, I want you as a group to make predictions. If you spin the spinner, and this is 66 D and E, if you spin the spinner 6 times, how many oranges should you get? If you spin the spinner 48 times, how many oranges would you expect? And if you spin the spinner 100 times, how many oranges would you expect? And that's part E. So go ahead and take a couple minutes with your team. Spun, by the way, spun is the past tense of spin. I heard spinned like 7 times during this class. Spun. Yeah. Would you have an answer? Huh?
20% is orange, 30% is green. We're trying to figure out orange.
I know, because our experimental results gave us some faulty data. Because we stopped at 10, orange and green were tied. I mean, there was nothing that we could do about that. They shouldn't be. Theoretically, they're not. But by experiment, they were tied. So our predictions are based off of what we know, what we can see now. So this is really, if we're playing along, this is 66 D. So, predictions for orange results. So if we say out of 6, how can we figure out of 6 spins how often it's going to occur? Yeah. So if we want to do 20% of 6, of tells me to multiply. So if I did the fraction, it'd be 20 hundredths. I like decimals better. Decimals are a bit easier to work with. So 20 hundredths, of tells me multiply, and we did 6 spins. Now, can I get a result a partial amount of times? You're going to land on orange half the time? Like, no, that doesn't. So you can either land on it or not, right? You do or don't. This doesn't come out to be a whole number. So if we want it to be a whole number, we can use these squiggly equal sign, which means approximately equal. What would we round to? The wholest number. I like it. The wholest number close is 1. Because we get about 1.2. And you can't have a result 0.2 times. So then for II, it's out of 48 spins. Ooh. So we can recognize 48 and 6 have the relationship between 8 times. So out of 48 spins, we would expect, well, do the same thing. We just expect about 8. Now, if we do the math, and did the 0.2 times 48, we actually get closer to 9. So either would be okay. So we're going to say approximately 8 or 9. We're not certain. Bless you. We're not 100% certain. But again, we're just making predictions. So we're being approximate. Any questions on how we make that prediction? So as your group, solve E the 100 times. If you haven't done it yet, as your group, solve E. So you wouldn't necessarily, depends on which multiplication you're asking about. So if you want to do 20% of something, 20% of tells us to multiply. If I hand you 3 sets of 5 pens, you have 15 pens, because 3 times 5. So one way to solve these percent problems is just do the multiplication and take your percent, either as a decimal or as a fraction. I could have done 20 over 100 times 48 and written the 48 like a fraction. I can multiply across and simplify, not cross multiply, but multiply through and then simplify it out. I'll get approximately 9. It's really like 8.8. Yeah.
I go to that.
Sure, we're almost like, we're close to wrapping. We're just doing the 100. How does 48 kind of relate to 100? If we're using approximate mathematics, how does 48 kind of relate to 100? They're both numbers. How does 48 relate approximately to 100? It's about double. It's a little over, actually. So if I wanted to be really approximate, I'd say around double of the ish, right? We're between 8 and 9-ish. So I could double that and say, okay, well, maybe 16 to 18-ish. But Bilal was asking, why did I do the multiplication? Of, as a math word, means multiply. Because if I hand you sets of something, you're multiplying. So I can, when I know that it's 20% of 100, now out of 100 would be division. But we don't know how many out of 100. That's what we're trying to figure out. So we need to make our 20%. Now, there's a few different ways we can solve this. We can set up 20% and say that has to equal the amount of, well, wait, hold on. If 20% means out of 100, and we're looking at spins, how many oranges out of 100? What's 20% of 100? 20. So our prediction is really just approximately 20. And we could actually do that by doing the 0.2 times how many spins you spun, and we get 20.
That's why.
Now, if we weren't spinning 100 spins, let's say we were spinning 300, then you can say, okay, how do I get there from my percent? And that would be about 60. But when it's out of 100 spins, it's easy. It's already essentially in percent form. Any questions on that? So your homework, again, over there, and was up here when you came in, is 70 to 74. Please make sure you get that taken care of. I'm going to start, and we'll talk about this tomorrow. I'm going to start just posting answer keys. I'll create a separate folder for it. I'll show you tomorrow. And we're not going to always go over homework together unless people ask questions. So it'll be an expectation that you check your own homework. We'll talk more about that tomorrow. Yeah. Okay. So not tomorrow. I always give you 2 business days. You have all of today to do it and all of tomorrow. For the first time, if you do, be like Thursday morning, I might say, okay, let me see your homework. I'm collecting it, but like I wouldn't check it the next day because I think you guys are busy. Like you guys might have games tonight or practices or church or who knows, but you're busy. You get 2 business days. Thank you guys very much.
I don't know what happened.
I'm sorry. Manage your time. AO and extensions. I also do that because AO and extensions. You only have AO every other day. That's also why.